So this is the URL that you should open that will bring you to this Notion document here that has all the information about this workshop and that I'm going to use throughout the workshop to walk you through the individual lessons. Next to this Notion document, I've also prepared a starter project that is in this GitHub repository here. So you can then go to GitHub when the time comes, not now, and clone the repository to get started with the actual lessons of the workshop. So first, I want to talk a little bit and walk through the Notion document to give you an overview of what to expect in this workshop. And then we'll dive in a little bit with a quick overview of what Prisma actually is, how it fits into your technology stack. And then we'll get our hands dirty with a couple of lessons that I've prepared. As prerequisites for this workshop, you really only need Node.js installed on your machine, where if you're attending a conference that's called City.js, I assume that this is one thing that you have already. And then I highly recommend to use VS Code as the code editor for this workshop. But of course, you can use any code editor you like. It's just that Prisma works particularly well with VS Code, and that's why I would recommend using it. But it's really a workshop that's designed for newcomers to the world of databases and also to Prisma. So you really don't need any prior knowledge about SQL or Prisma itself to be successful in this workshop. So in this workshop, you'll learn about various workflows that are useful to know when using Prisma. And you'll start by setting up a Sqlite database. And we use Sqlite in this workshop because it's a little bit simpler to get started with it as a database. You don't need to run your own server. You simply have a database file that's on your file system that you can access there. So it's very straightforward, doesn't require any prior setup. We don't need to run anything in Docker. We don't have to set up the database server. So it's a lot simpler. And that's why we're using Sqlite here. And then in the first lesson, you learn about data modeling with Prisma and performing database migrations. Then we'll start talking about Prisma Client, which is a type-safe query builder that can be used to query your database from a Node.js or TypeScript application. And in that lesson, we're going to explore various queries from plain CRUD to relation queries, filters, and pagination. And then I want to also give you a sense of how Prisma fits into the world of API development. So rarely you'll have the situation that you just need to access a database inside of a script, or even a CLI tool is not that common, I guess, to work with databases. The most common application for databases are web APIs, web applications. And so I want to show you how Prisma fits into a REST API and into a GraphQL API that we're going to build with Express and Apollo. And here's the agenda that I've prepared for this workshop. So I've planned, and we are like a little bit behind, but that shouldn't be a problem. We can catch up along. So we start with the welcome and kickoff, where I'm also going to walk through what Prisma actually is, give a high-level understanding. Then we'll get started on the practical lessons, setting up Prisma, data modeling migrations, exploring Prisma Client for querying the database, and then implementing REST and GraphQL APIs. Here are sub-pages that you can click on that then refer to these lessons. We'll start with these soon. You don't need to click on these yet. And for each lesson, I want you to be aware that a lesson is structured in two parts. First part is the host walkthrough, and that's basically me showing you what to do in this lesson and explaining to you the things that you have to be aware of. So like nobody expects you to just start diving into these lessons and being able to complete them. Rather, you will have some time where you can watch me do something, and then you can apply that and try that out yourself. And my recommendation here again is that I would recommend you that you do not code along or work on the task yourselves, as long as I am showing what to do. And that's really just for you to absorb and understand the context of the the lesson because I'm going to explain some things to be aware of. So I would recommend to not start until you actually get the time to do it yourself. So at the end of every lesson, you will have 10, 15, 20 minutes to work on these tasks yourself. All right, who am I? Who is this clown that's sitting here in front of you and wants to talk to you about databases? So my name is Nikolas, and I work at Prisma as a developer advocate. You can reach me through these channels on Twitter, on GitHub, via email, and at Nikolas Burk on the Prisma Slack as well. One small note here that I want to make is that this entire document, this like Notion document that's the foundation for this workshop, is public. And I have no problem whatsoever with you reusing the materials that I've prepared for this workshop in your own communities, in your own meetups, or in your own companies with friends to teach people about Prisma if you like this workshop. So that's not a problem at all. You can just go ahead and reuse these materials. And I highly recommend that you do that because teaching workshops is actually a really fun experience. And I have to say it's even more fun in person, but even online, I do enjoy it. And yeah, if you want to learn more about Prisma and become part of our community, then I would also recommend you to join the Prisma Slack with more than 50,000 developers by now that are all excited about Prisma. So let's get started with the first lesson that is here. And the goal of this lesson is to set up Prisma, get comfortable with Prisma's data modeling language, and perform your first database migration. And here we now start with the setup. And so remember, this is now just the host walkthrough. So you're not supposed to do anything yourself yet, but instead, you'll get some time later as soon as I tell you that you can get started. So the actually, sorry, I just remembered that before I wanted to give a quick high-level overview of what Prisma actually is, what problems it solves. I didn't want to skip that. So for that, I'll just open the Prisma landing page actually and explain it by the concepts that we have outlined here. And I want to start down here with this diagram, how Prisma fits into your stack. And this kind of diagram, a lot of you are likely familiar with. It's this kind of very typical three-tier architecture that most modern applications are being built with. And on the one hand, we have the client applications that could either be mobile applications or front-end applications that run in the browser based on frameworks like React, Next.js, Vue, Svelte. There are a number of different front-end frameworks that proliferate today. These front-end frameworks, they need to show data. And the data is usually coming from the backend. And the backend is what we loosely refer to as the server and the database right here. That's the backend of the application. And the backend consists of two main components. One is the API server, and one is the actual database. Well, the API server is running a proper backend application as well. That's, in our case, will be most of the time written in JavaScript. So it's running on Node.js, but it can also be written in any other programming language. But if we are in the Node.js ecosystem, then developers have to make a choice for how they want to interact with their database. And they have a couple of different options here. The most kind of straightforward option, the most naive way in a way, is to just write plain SQL queries if you work with a relational database. So for that, you can use these low-level database drivers, install these in your project as NPM libraries, and then open a connection to the database and write plain SQL queries. So then you operate at a very low level of abstraction. It comes with a lot of kind of manual tasks. You don't get a lot of like a nice developer experience with auto completion because you typically need to submit your SQL queries as strings. So it's not quite a nice abstraction to work with. And if you don't know SQL, or if you're working in bigger teams, then this is often not the preferable way. You rather want to work with some kind of abstraction over SQL itself. And that's where the idea of object relational mappers, ORMs, is coming in. Object relational mappers are tools that are mapping from a relational database, the data structures from a relational databases, to object-oriented structures in your programming language. The main difference between the two, by the way, is that in a database, you typically store data in a normalized or flat structure, and then you cross-link the tables via what's called foreign keys. And in object-oriented programming languages, you can have deeply nested structures. So it's not that the objects in your code typically like reference each other via these foreign keys, but rather you just have nested structures that represent your data. And that's exactly what Prisma does. It's an ORM that makes it easier for developers to work with databases by providing that kind of higher level abstraction, making it a lot easier and honestly, like giving developers more confidence and productivity for their database workflows. Before we jump in, I quickly want to show you on a high level how Prisma works. So one really cool thing about Prisma is that it has this human readable data model. As opposed to defining your table structures, the SQL schema with SQL code, in Prisma, you can actually use this modeling language that is a lot nicer to read, and that also has a great developer experience when you're modeling data inside of VS Code because of Prisma's VS Code extension. And once you've done this, you can apply your data model to the database by actually generating a database migration. So here is where Prisma Migrate comes in. Prisma Migrate reads your data model and it generates SQL code for you that you can then apply against the database. And if you need to customize your migrations, the SQL code that you want to run, that's also totally possible with Prisma Migrate. So it's not locking you in to only use the features that you have available in the Prisma data model, but instead you can really use all the features that your SQL database provides. And then when you have the database schema in place, everything is ready to go for you to start coding, then you can use Prisma Client, this type-safe database client that you can use to send queries to your application. And of course, under the hood, Prisma Client is also going to generate SQL queries because ultimately that's what the database understands. But you don't have to worry about that SQL. And instead, you can just use Prisma Client's nice and intuitive querying API to start retrieving data from your database. And with that, I have introduced the most relevant components that you need to be aware of today. And we can continue moving on to the actual lessons of today's workshop. So I'm going ahead and clone the starter project from GitHub. I already have it open here. And to clone and to follow the workshop, you can simply follow the instructions in the README right here. So first I'm going ahead and opening a new terminal here. And I'm going to clone this on my desktop. And as a next step, I'm navigating into that directory and installing my node dependencies. And then I'm opening this directory inside of VS Code. All right, let's quickly take a look at what is inside this project, inside this repo. So if we look at the package.json, it's really very, very simple. The only dependencies that we have really is Prisma Client. That's the only NPM library that we use. And then we have a couple of dev dependencies that we're using at development time. And that's just the Prisma CLI, as well as our tools to get TypeScript up and running. So we'll be using TSNode to execute the script that comes with this project. So here is just a very simple TypeScript script that we are going to use to explore Prisma client queries. And then we also have this Prisma directory right here with the Prisma schema. And the Prisma schema, we already saw it when I was talking about the data model, is the main configuration file for your Prisma project. And we already have two components in here. One is the data source, and that defines the connection to our database and also which database we even want to use. So in our case, we're using Sqlite, but here you can see all the different databases that Prisma supports. And if you want to use a different one, then you can just use a different data source provider here. And this is the connection string or the connection URL for the database. I mentioned before that Sqlite just uses a plain database file on the file system. So I want this file to be located inside of the Prisma directory as well, and want it to be called devdb as soon as we are at the point that we create it. And then we also define this generator here, which means that we want to generate the Prisma client API for our data model. All right, so let's take a look at our first task. Create your first Prisma model. And so here's just a quick recap of what I just explained. And here is now the task. So start by creating the following user model with the following fields and choose the data types that feel the most appropriate to you based on the description below. So we're supposed to create a user model with an ID, with a name and an email. And the way how you define a model in Prisma is by using the model keyword and then using curly braces in which you then define the fields of the model. And we first want to create the ID field. It should be an auto incrementing integer. So I'm choosing the int type here, and as a default, I'm going to assign an auto incrementing value. Then we also need a name for the user. I'm just going to make this a string. And then we're also going to use an email, and that's also going to be a string. So at the moment, Prisma still complains because you need an ID, a unique field on any model that you create. And at the moment, I haven't specified that any of these fields should be unique. And because we're working with relational databases where it's also common to use primary keys, I'm using the @id attribute on the ID field to indicate that this should be the primary key of this model. I can also format the Prisma schema so that it's nicely aligned in this columnar layout. And then if we actually look at more requirements for the fields that are like mentioned here, is that one field should be optional and the other one should be required but unique. So the way how we can make a field optional is by adding the type modifier, a question mark, to the type of the field. And to make a field unique, we cannot add the ID attribute because any model can only ever have a single ID, only one primary key. But we can use the @unique attribute, and that just translates to a unique constraint in the underlying database, so that the database is now going to make sure that we can never have two user records that have the same email. All right, run your first migration. The way how to run migrations in Prisma is to use the Prisma CLI, and more specifically, the Prisma migrate command. So with the Prisma CLI, you can invoke it by prefixing it with npx. That's a little bit safer because that means you're always using the version of the that you have installed via a dev dependency and not accidentally a global installation. That's why we recommend it to invoke the Prisma CLI with npx. And you see a bunch of different commands that you can invoke. And to run migrations, we want to use the npx prisma migrate dev command. That's for development. And then if you want to deploy your migrations in production, you can use the prisma migrate deploy command. And then we also assign a name to this migration, and this migration, or like this name of the migration, is going to determine the name of the new folder that's now being created on the file system. And let's actually take a very quick look at what happened here after I ran this command. So Prisma just created for me a bunch of new files and folders. One of them is this migrations directory here. And inside there, we have a folder that's called init, prefixed with a timestamp. And inside of that, you have a SQL file, and that shows you the migration, the SQL code that is being created. And then also the Sqlite database actually has been created. As I mentioned before, I want it to be called dev.db. That's exactly what Prisma now did. So we already have a database. We already have a database with a user table in place after running this migration. The next task is to create some data in the new database in Prisma Studio. So Prisma Studio actually is a really nice tool that I haven't mentioned yet. It's a visual editor for your database that you can use to view and edit data. And in this case, I'm going to create 3 records for this workshop. So this is the first one, and then I'm going to use some of my colleagues here to add more. 7 is another developer advocate at Prisma who just joined our team yesterday. And you should follow him on Twitter, by the way. All right, so this is the way how you can create data in Prisma Studio. And with that, we're at the end of lesson 1. And I'm now giving you all about 10 minutes where I'm going to turn off my mic and my video so that you can go ahead and work on these tasks yourself. If you have any questions, you can drop them in the chat. And otherwise, I will see you here in 10 minutes. And we are back. All right, I hope you all had fun working on the first lesson and were able to create your data model and your first migration with Prisma, and then also stored some data in the database. So now we're moving on to the second lesson. And in fact, because I think most of you are watching on Twitter actually, and this entire workshop is a little bit more asynchronous. And I'll probably just shorten the time for each interactive part where you get the time, and rather work through the examples a little bit more myself and explain a little bit more, so that even the people who are just watching on Twitter, who maybe are not like following that intensely, still get something out of this workshop. So let me continue now with the second part. So remember, we just created our data model, we just created our first migration, and then inside of Prisma Studio, we also created the first records for our database. So let's go ahead and look into lesson 2, where it's all about Prisma Client. So the goal of this lesson is to get comfortable with the Prisma Client API and explore some of the available database queries that you can send with it. You learn about CRUD queries, relation queries, filtering, and pagination. And along the way, you will run another migration to introduce a second model with a relation to the user model that you created before. And of course, that makes sense if we want to explore relation queries, learn about how we can modify multiple models in a single query, then we need to have a relation in the database as well. And we're going to set that up later. You can continue working in the same Prisma Workshop project, so you don't have to change anything for this lesson. So now let's take a look at the script that I already quickly showed before. And we just have this main function here. And what this does, it just gets executed. Hello, city.js when I run npm run dev. So I just quickly want to show you that's the setup for this lesson. And we'll use the main function to explore the Prisma client queries. So let's see what we're supposed to write here. Some tips and recommendations again before you start. So if you actually follow this workshop yourself, I highly want to recommend you to type yourself and not copy paste the solutions that are available for every task, for every listen. Then I would also recommend you to use the auto completion. And of course, you already used Prisma Studio in the first lesson, and that'll be a helpful companion for you along the way to just validate that you did the lessons correctly and that the state of the database is correct. At the end of the task, each task, you can run npm run dev, as I already showed you here, with just this simple console log statement. And so the first query that we'll have to work with is a query to return all user records and print the result of that to console log. So the way how we are going to do this is by creating a new variable called result. And inside of that variable, we want to store the result of the database query. So the way how we can invoke a database query is first by using the await keyword, because all Prisma client queries return promises. And instead of using .then and then doing something with the result, we actually use async await here. And then we already see that Prisma client was already instantiated up here. So what I can do is I can just type the name of this Prisma instance, and then I hit dot to start using the auto completion that can also explicitly be invoked with control space. If you hit control space, then you always see all the available query options that Prisma client provides. Just courtesy of TypeScript, by the way, because TypeScript generates all of the type definitions for Prisma client that enable this here. So here is the only model query that we have available. So all of these prefixed with $, are top level queries that we don't really have to worry about right now. And instead, we just want to send a query for our user model. So we just go ahead with prisma.user. And because I don't want to go and look up the documentation to figure out what kind of query I am now supposed to write, I'm just going to use the auto-completion again with another dot. And here we can see all the different functions, all the different queries that I can call for the user model. And in this case, we are supposed to write a query to return all the user records. And we can do this with the find many query. At the end of each query, we have to put parentheses because these are functions that are being called, just regular JavaScript functions. And we just print the result to the console. So if I run this now, what do I expect to see? I expect to see that we see all the records that I have created previously in Prisma Studio. So 3 user records. I'm running it with npm run dev, and indeed, we just see that this is exactly what we get here. So the next task is to create a new user record with only an email, but not with a name. So this time, I can keep the .user because I still want to operate on the user model. And I'm using the create query because that sounds a lot like it would create a new user record as I am tasked here. And I open parentheses, and this time we have to provide arguments to the query. And if I don't know what kind of arguments they take, what it looks like, again, the auto-completion inside of VS Code is going to help me with control space. I can invoke it, and I see that I can either provide a data or a select option here. The data option is required, so I actually have to provide it anyways. And again, I'm not quite sure what I can provide using auto-completion. And I see that I can provide the fields that I declared on the user model when I create one. And that makes sense because these are really the kind of fields that I want to equip the new user record with. And so here in the task, it says that it should only have an email, but not a name. And we can even see that the ID and name are both optional because name, we actually marked that as optional inside the Prisma schema. If you recall, we added the type modifier here, the question mark. So not every user record needs to have a name field or a value for the name field. And then when you have a default value for any field inside of a Prisma model, that's also optional. So we also don't have to provide an ID because in our case, that's going to be auto-generated anyways. So we are supposed to create this email, ls.prisma.io. And if I now run this, I expect that the new record is being stored in the database and that it's also being printed here and exactly in the shape that we also expected, with an auto-incrementing integer as its ID, with no name and with an email. If I want to convince myself that this actually worked, I can use Prisma Studio again. It's opening here, and we see that indeed the new user with the email has been created. So write a query to update an existing user record. In this task, you will update the user record you just created and add a value for its name field. That could have been done in the same step, I guess, but we now do this in 2 different steps. That's okay. We just want to explore the CRUD capabilities of Prisma Client. So after reading and creating user records, we are now learning about updating user records. And here we have the proper query that we can use for that. And if we now look at the options that we have available, data and where are both optional. So I need to provide these. And if we think about it again, that kind of makes sense. So the where option first is used to identify which record I want to update. And here I can either choose the ID or the email, because both of these are unique. Both of these fields allow me to identify uniquely a record in the database. A user record in the database. So In this case, I could go either with ID 4, but this feels a little bit brittle because if I accidentally use the wrong ID here, if I if I hadn't remembered it from before, then it just makes more sense to actually use the email right here. We still get red squiggly lines because we are not yet providing what we want to update. So Prisma complains about that. And we can, with the data option, we can specify what fields we want to update. And in this case, it's the name. And can go ahead, run this. What's being printed is the same object as before, except that now it does have a name. And if we go back to Prisma Studio and refresh, then we also see that the name was also updated here. The next task is to add a post table to the database. And for that, we go back to the Prisma schema and to our to the way how you model data with Prisma. So first off, I'm just going to copy the user model to have the boilerplate ready here for my new model. So I'm going to call this post. And then I'm taking a look at the different fields. So let me see, there is a title. I want to make this of type string. Content also of type string. Published. This indicates whether a post is published or not. So it really has two states. I'll make this a Boolean. And then there needs to be an author and author ID. So the author is the user. I'm going to make it optional. So a post can also be created without an author and an author ID. And that's the foreign key that relates the post to the user model. Remember how I explained in the beginning that relational databases have this flat or normalized way of representing data. That's what you see here. So the author ID is this foreign key, this reference to the user model, so that when we create a new post record and we set this author ID, then we can know which is the user who is the author of this post. And when we need both the post and its author in our application, we can perform a join between the two tables. But with Prisma, that's even easier. We don't have to actually drop down to the level of SQL joins, but rather also can use Prisma's intuitive API here. In order to complete the relation, though, we have to create some more attributes here. We have to tell Prisma that this relation field of type user uses this this foreign key field to reference the user model. So here's what that looks like. References ID. And just to make you aware, this ID field here refers to this ID field on model. So that's how we connect the author ID and the user ID. And it still complains because, in fact, in Prisma, when we define relation, we always have to define the relation on both sides. So here is what it now looks like. I'm also going to format it again. So we now have this user and post relation. We have two relation fields that I can use later on for my relation queries in Prisma client. And there were a couple of more requirements for the data model that I just ignored in the first place. So the content actually should be optional. So I'm adding the question mark again. Published is required, but we'll add a default value of false so that every new post that's created in the database will first be false, will first be not published by the published field being set to false. And then later on, we can flip it to true. And that means that the post is now published. Let's see what we're supposed to do here then. Once we're done, we can create a new migration. I'm using the same command as before. This time I'm naming the migration add post. And if we look at the migration that has been generated this time, we can see that a new table is created, and this is all the SQL that is now being or has now been executed against the database. So you can see that it looks a lot more verbose and frankly complicated than the Prisma schema right here, which in my mind seems a lot cleaner and a lot more readable than this kind of SQL code, where it always feels like SQL is shouting at you with its convention of always spelling everything in uppercase letters. All right, we have the new table in place. The next task is going to be back in our script. So let's see what we're supposed to do here. Write a query to create a new post record. Let's do that. We already know how to create new models. And actually, if I'm now using the auto-completion, under the hood, Prisma client was regenerated, and also its typings were regenerated when I ran the migrate dev command. So now I actually not only have the user option available here on my Prisma client instance, but also post. And that can be used in a very similar way to how I worked with the user model before. So I'm using data. And for this one, I'm supposed to only provide a title. I'm going ahead with npm run dev. And it prints my new post record, ID of 1, and a title of hello world, and a published field of false. And the other two fields are not specified as expected, since these are optional and I didn't provide any values for their fields. Now we will go and write a query to connect user and post records. So we now already have several user records and exactly one post records in the database. And these can now be connected via the author ID foreign key column. When using Prisma Client, you don't need to manually set foreign keys, but you can configure relations using Prisma Client's type-safe API. Can you figure out how you can update the post record and connect it to an existing user record via the email field? So let's see if we can figure that out indeed. Post.update, we already know that from before. So there's just another CRUD query that we're going to perform. So this post that we want to update here has ID 1. I can still see that here in the output. So I'm pretty confident about it this time. And now we are starting the dance to update the post and assign an author to it. So right here, I'm using the author field, and I'm just, again, using the auto-completion to guide me through this query that I want to write. So in this case, I just want to connect the post with an author via the email field, and I'm going to assign it to the user that I had just created before, alice.prisma.io. And if I run this, we now see that the author ID has been set through this API call. So if you recall, in the previous query when I ran this and I only created this record, the author ID was null, and now it's set to 4. Let's move on to write a query to retrieve a single user record by a unique value. So in task 1, you learn how to fetch a list of records from the database. And in this task, you need to retrieve a single user record with a Prisma client query by a unique value. So let's see if we can figure out the right Prisma client query for that. And I'm just going to repeat myself and sound like a broken record here. But again, I'm using the auto-completion. And it's actually not only delightful when you can do this in the context of a workshop like this, but if you actually do this at your day job, where you can write the queries that you need just on the fly without always going to the documentation, looking up certain queries, that's just a big productivity gain. So in this case, I want to select a single user record by a unique field. And I am going to use the find unique query for that. Just as the update queries, this takes a where option. And I can search by any unique field. And I'm going to use ls.prisma.io here again. Oh, there was a typo in my query. So it's IO, not OI, of course. That's why Prisma client returned null. There is no user with that email. And now, as we expect, we do see this. We do see the user record being printed out. Now, actually, you'll notice that the relation fields that we have defined on the models, they haven't been printed. And we'll just come to talk about this in just a bit. But the relation fields, they are virtual. That means that they don't exist in the actual database where the data is ultimately physically stored. But these fields, they are virtual. They don't exist in the database. The database has no values for these. These are here purely for your convenience to have an easier time modeling the relations that you're going to use, but also to query the relations that you're going to use. And we'll learn about that when we start talking about relation queries. So in this task, we're going to write a query that selects only a subset of fields. And for this task, you can reuse the same find many query for users that you used in task 1. However, this time your goal is to only select a subset of the fields of the user model. Specifically, all returned objects should only contain the ID and name, but not the email fields. So let me go back and use a find many query, and let's figure out how we can select a subset of fields. So if I use the auto completion here inside of find many, I see all the options that this query takes. And the one that I'm looking at right here is select. And that's because it sounds a lot like it would help me select a subset of fields. So if I do this and I provide this as an option and I just follow along again with curly braces and use the Prisma client queries auto completion to see what's available here, I can now select the different fields of the user model. And these actually determine what kind of fields will be returned in the response. And here I'm supposed to only return the ID and the name field. So the way how you do this is by specifying these fields as true inside of the object. And this is ID and name is what we wanted to retrieve. So let me go ahead and run this. We're not changing anything in the database. We're just changing what we want to retrieve from the database, and we're omitting the email field. So if I were to just remove all of this here and run this again, it prints by default all the scalar values of a model. And if I use the select, and for example, I could also remove the name to make it even clearer, then we're only retrieving the ID. And that's especially interesting because you'll also notice that this result here, this variable, is being typed properly to the return type that is being expected. So it's really only an object with one ID field. So the TypeScript compiler is smart enough to infer that. And where it becomes really beneficial is if you need to access the fields that you're retrieving from your models. So in this case, I could do something like this. And if I try to access a name field on here, then that's just not possible. The TypeScript compiler will not compile the code because the types don't match up. I cannot access a field on the result here that doesn't exist because I didn't retrieve it from the database. But as soon as I include it, the TypeScript error goes away. and it will actually go ahead and print the name of the first user in the array that was retrieved. All right, the next one that I want to show is write a query that with a nested to include a relation in the result. So you'll now start exploring more relation queries of Prisma Client. Let's start with a nested query where you include a relation. Concretely, take your query from task 7 and include the relation to the post table in the result. So query from task 7 was this one. I'm just being lazy now and copying and pasting. It was the one where we used find unique. And the way how we can also include a relation, let's actually check with the auto completion. There is the include keyword that I am going to use now. And here are the posts that I want to use. And the API is actually similar as for selecting fields. So if I run this now, I'm going to select a user object that has nested data with posts. So that's, again, like back to what I explained in the beginning about the flat and nested structures, the normalized and flat structures in the database. We have two different tables, one user table and a join and a post table. They reference each other with a foreign key. And in this case, in our application, we now have a nested structure because under the hood, Prisma Client performed a join for us. It joined these two tables based on the information that we provided in this Prisma Client query. So that's how you can retrieve relations from the database here as well. Okay. I'm going to do one more query here. And that's the nested query to create a new user record with a new post record. So we're basically creating two records now. And I'm using the auto completion again, user.create. We already know this. We already did this. And let's take a look at the data that we want to provide here. So I'm going to create a new user. Let's call them Bob. And we'll also add a name. And now we also see this posts field here. And by the way, I did mention that when I was talking about include, but the reason why we see this post field is because we defined the post field as a relation field here on the user model. That's why we see this. And that's how the name of this field is determined. Here we can say that we want to create a new post with a title. Bob is very creative for his first post here. And that's the query that you can run. You could also go the other way around, by the way. You could also go and say you want to start with a post. And in this case, of course, the email and name you cannot use anymore because these are only for the user model, but you can pull the title on this level. And again, if you follow the auto completion, you could say that the post is created along with its user record. And it doesn't matter which way you choose. I'm going to run it like this now, but it really comes down to exactly the same thing. All right, with that, I want to leave you for a few minutes again. This time I'm just going to stop my video for only a couple of minutes. I mentioned before that I want to make this a little bit more, or like I want to show here a little bit more rather than like giving you a lot more time, because I think most of you are just watching on Twitter. So it's probably boring for you if you're not following along practically. If you have any questions, by the way, on Twitter, you can just drop them in the thread is like created just under this tweet, and I'll pick them up on the stream and address them after the break. All right, let's move on here. So we are moving on to the next lesson, the REST API. And for the setup of this one, the way how it works is that first we're going to stash everything that we have created so far, since we're in a Git repo. And then we can go ahead and check out the REST API branch of the repo. We're also removing the Prisma migrations folder and the dev.db database file. And also, just to have a fully clean slate, we're removing the node modules folder and reinstalling our dependencies. So let's take a look at this project now and how it's different from the script project that we had before. So first of all, the data model that you see here is very, very similar to the previous one. So we have the same user model, we have the same data source and generator blocks. The only difference really is that the post model has a couple of new fields, the created at field and the updated at fields, as well as a view count field that was being initialized with a 0. So every new post that's created in the database has 0 posts. And we're starting from a completely clean slate. So we don't have a database anymore. We don't have a migrations folder anymore. Yeah, let's move on to see the tasks here. So first, to finish our setup, of course, you will know this by now, we have to run our migration. We're using the Prisma migrate dev command. And this time, if we look at the migration, both tables are created in the same migration file. So previously we had 2 migrations, one for the user table and one for the post table. This time we just create everything at once. And then also to note is that we have a seed file right here where we're already seeding some data into the database. And we actually can see that the seed command has been executed automatically after running Prisma migrate dev. So all the users have been created. And if we want to take a look at that in Prisma Studio, we can restart it. It'll pop up in my browser. And indeed, we can see that we have these user records right here. All right, let's take a look at just to still get an overview of the project file. I just want to show you what we have here. There is the package.json file. It has pretty much the same dependencies as before. So Prisma client, Prisma and TypeScript. But then we also add extra types because we're now using also the Express library to build an HTTP-based web API. And then instead of a script.ts file, we have this source /index.ts file that has predefined routes for the Express server that we're going to use. So in fact, this is already runnable. We can start the server. It will listen on port 3000 when I run npm run dev. And if I open that in the browser, should be familiar to you if you have worked with Express before. This is just the error message that arrives when you have no method defined for a specific route. And if I do app.get/users, we run into an infinite loop because the users route is defined for a GET request that we send with the browser, but because nothing is implemented, we only run into an infinite loop here. So let's kill the server, stop the server, and look at the tasks. I also have prepared a test file that you can use. I'll show that in a bit. And all the tasks here, I have expanded all the solutions. Sorry, I'm just going to collapse them again. all the solution, the tasks here are based on the routes that you also find in this file. So in fact, you can approach every task in the same way, that you uncomment the boilerplate code, and then you use the same kind of Prisma client queries that you have used before. So for example, this is supposed to return all users. So we are going to return all the users here. Let's also implement a few more. So the signup can be implemented by using prisma.user.create, because we're creating a new user. We have the name and the email already extracted from the body of the post request. So we can just provide it like this, actually, data and name and email. This is to create a new post. And the way how we're going to do this is again by using the .post option on Prisma client with the create query, and the data we provide is the data that we retrieved from the request body again. So we have the title, we have the content, and we have the author email, which we cannot directly feed into the Prisma client query. If you remember from the previous lesson, we have to connect it with the existing author. We're using the variable, of course. All right, so let's actually go ahead and test this for now, because we now implemented 3 of our required queries. So I'm going to start the server again with npm run dev. And next, we're taking a look at the test.htp file. And if you're using VS Code, then you can install the VS Code REST client extension that I have here. And that extension enables you to send the HTTP request that you have defined right in this file, which is very neat. And in the simplest way, a HTTP request really looks like this. It's just the method of the HTTP request, a GET, and then the URL where we want to send this to. So the REST client extension is going to execute this request for me. And indeed, it works. And we can see the new the users that have been seeded into the database and that we also already saw in Prisma Studio. The next request is a post request for the sign-up route that we implemented for creating a new user. This time we have to provide a content type because we're providing JSON data to that query. This is the new user that we want to create. So let's go ahead, send the request, and indeed a new record seems to have been created. Now, what happens if I send this again, by the way? Can you guess? Well, I personally would expect an error because I would send the same request with twice that tries to create another user with the same email address, even though we defined a unique constraint, if you recall, on the email field. So that shouldn't be possible. So let's test that. And indeed, in fact, the server crashes because Prisma client throws an exception and we haven't implemented any error handling ourselves. So this doesn't work. I have to restart it. And I can send the post request to create a new post record here as well. And it's all as expected. Default values for created at and updated at, no content, default values for published and view count, and it's connected with the author ID of 1, and that should be the user Alice. We can validate that again by checking at the users, and that's indeed the case. Okay, let's look at a couple of more queries that we can implement here. So this one is interesting. It's a put. Put method. That means that we want to update something in the backend. That's HTTP's ways of expressing that. And we're indeed updating the posts, the views of a specific post. That's what this like notation here means. And this like colon ID here refers to a variable that we're going to include in the URL itself to indicate which post we want to increment the views of. And just to validate, this is indeed what we're supposed to do, increments the views of a post by 1. So let's uncomment the boilerplate and figure out how we can do this. Await.prisma.post, that is certain. And then we want to update this post because we want to increment the views. So let's first specify which post we have to update, and it'll be the one with this ID. And we have to cast it to a number, by the way, because it comes out as a string here, and we're using integers as IDs. So let's specify the data, and it's the view count that we want to change. So let's see how we can do that. There are these, what we call atomic operations on the view count here, and we can increment or perform other mathematical operations on this field. So we're incrementing it by 1. I'm going to implement a few more. I skipped the publish for now. This one, the drafts, fetches the unpublished posts of a specific user. So let's see how we can do that. We receive the ID of the user, and we can say await.prisma.post. Find many. So now we have to apply a filter, actually. We're using where. So first, by a specific author. So for the author ID, we're providing the ID field and we're casting it again. And the second condition is that it should be published. And that should be true. So this fetches only the published fields. All right, let's also, actually, no, I'll leave this as an exercise for everybody who's watching to implement the remaining ones. And if you don't get far, then of course you can look it up in the Notion document. So let's restart the server and test the queries that we did implement. So we did implement the incrementation of the views. So that's how this works. And you see that the view count and the updated add fields change upon each request that I'm sending here. So that seems to work. I also implemented the draft. So let's see all the drafts for the user with ID 3 in this case. And we get a single post back for this user with the ID 3 that's published. And yeah, that's actually, sorry, that was my bad. Of course, we need the unpublished posts for the draft. So in fact, I should make this false here, but this is just a minor detail. It's what you would consider a bug in a production application. And we see that here is another that's actually false. All right, so far so good for this lesson. I hope you took some parts away of this. I'm going to take a 2-minute break again, and then we'll move on to the final lesson And I'll show you how to implement the same operations in a GraphQL API with Prisma. And we are back. So let's wrap this up and move on to the next and final lesson of this workshop, and that's the GraphQL API. So let's prepare the setup for this lesson as well. So just as before, we are stashing everything. We don't need it anymore, and we are moving into a new branch of the same project. We are deleting the migrations, we're deleting the database and reinstalling our node modules just to make sure we're starting out with an entirely clean slate again. And the data model is the same from the REST API. And just to complete the setup, we have to go and run a Prisma migrate dev. It's not too late to ask any questions, by the way. So if you have questions, you can drop them on Twitter or right under the tweet where you're watching this, and I'll pick them up when I'm done. So let's move on with the next lesson here and the next tasks. But first, let's get an overview of this project by, again, looking at the dependencies. This time we're not using Express, but we're using Apollo server and GraphQL, as well as the GraphQL scalars dependencies, and then some additional typings here that are needed when working with these tools. We have a single index.ts file that defines the GraphQL schema. The GraphQL schema is the schema that is used on the API layer and determines what kind of operations the API can receive. And that's pretty similar to basically the implementation of the API routes in the Express project that we just saw. It's just a different kind of mechanism that, in my opinion, is a little bit better because it also enables you to determine already upfront the kind of data structures that are being provided and returned by all the operations. So we define a user type and a post type in GraphQL, and then these query and mutation types, they are actually the types where you define the actual operations that you can send to the API. And then you have these so-called GraphQL resolvers, where you then actually implement the code for these operations. So let's see if we can run this already. Oops, sorry. Just opening the terminal, npm run dev. And it's running at localhost 4000 in a GraphQL playground. So the server itself works, but the query doesn't yet. It gives us the error, cannot return null for non-nullable field, query all users. This error message is there because we are telling in the schema that we always have to return at least an empty array here. That's what's indicated by this question mark, by this exclamation mark. And the array also cannot have any null objects. So that's what's indicated by this question mark. And at the moment, if we look at the implementation of the resolver of the to-do function of the all users query, we see that we actually don't return anything here. So it's very natural that it complains. And the way how we can fix this is by now calling Prisma in the same way that we did in the REST API route before, and returning a bunch of users. So let me restart this and rerun the query, for now without relations. Server is running. Oops. And we can see that it indeed returns all users. The cool thing about GraphQL, as you can already see here, is that with GraphQL, you can also retrieve relations just by describing the shape of the relation that you want to retrieve. So in this case, I also would like to retrieve the posts with their ID, title, and published fields for each user. But if I do that, for some reason, even though the users already have created some posts, the returned arrays are actually empty. And the reason for that is that when you're implementing a GraphQL server, you need to implement these type resolvers for relation fields. I could actually also fix this problem by using include here. And that's what some people do to just get around this issue of resolving relations. I'm going to restart the server, and you will notice that this is solving the problem. And now the posts of each user will be included in the response. I guess it's actually overwritten by the type resolvers. So just assume that the type resolvers weren't there. Let me start it again. And if I now run the query, then include actually solves the problem, and we now include all the posts for each user. But this is actually not the right way to do things here, because this means that even if I don't request the relation here in GraphQL in my query, and I run this, the code that will be executed still this include operation here. So on the database level, there will be a join that will be performed. And that's not nice if I don't even request the relation data in my query. So that's not the way how to solve this problem, but rather you are going to solve it by implementing these type resolvers. And the type resolvers, you only need to implement the relation fields here. And they follow a very specific pattern. And to understand more about this, if you really want to dive deep, if you really want to dive deeper into how this works under the hood and why this is the right way to query things, I would recommend this article from the Prisma blog, type defs, GraphQL server basics, GraphQL schemas, type defs, and resolvers explained. So this is a deep dive into the GraphQL resolver system that explains the why these kinds of type resolvers are necessary on a technical level. But to implement them, we can just follow the structure that I'm outlining here. So prisma.post. Actually, sorry. We can't access Prisma, we have to access it via the context. And then we say find unique, where ID parent.id. So we're accessing the ID of this. And again, to understand why we need to write the resolver in precisely that way, go and check out that article. And then we're using Prisma Client's Fluent API to access the author. And this here follows the same pattern. So again, we're using Prisma Client to first retrieve the right user using find unique. And again, where ID parent.id, because that is the ID of the user that we now need to access. And we're using the Fluent API of Prisma Client to retrieve the posts. So restarting this. We can now actually include the relations. And because we implemented the type resolvers for both sides, we can actually nest. Oops. We can actually nest the data that we want to return. I don't think it makes a lot of sense to do this because we have data on a higher level, but it is possible to do it like this thanks to the type resolvers. All right, and with that, I want to wrap up the workshop. Thank you all for joining me today. Let me quickly check if there were any questions on Twitter that I can pick up before I leave everybody. Doesn't seem so. We have a few viewers. I saw a couple of viewers also throughout the workshop. So I hope everybody liked it. And I hope to see a lot of you soon again. And join our Prisma Slack, join our Prisma community if you want to start building applications with databases and use Prisma alongside. Thank you so much. Bye-bye.